G'day trendsetters. In this video we meet with Jonathan of Framework Bicycles, hailing from Hamilton, Ontario, Canada. If you missed it, Jonathan is the founder of Framework Bicycles, a machine I reviewed recently, namely a Framework Bicycles custom gravel bike. You can check it out, linked in the description below. It is absolute insane precision on another level. So it's time to learn from Jonathan about the brand Framework Bicycles and what goes into every bicycle he produces.
Started making bikes during the pandemic, partially for a bit of a passion project, but also because you couldn't really buy anything at that time. So my wife and I own and operate a machine shop, and we do tool and die making and machining in like aerospace and medical industries. And we had just completed a large project for our local government making COVID supplies for PCR testing. So I had a bit of free time on my hands, and yeah, I've always been into bikes, so decided to try to make one, and it's more or less snowballed from there. I did one as a one-off and just started riding it around town and some group rides and stuff, and had a lot of positive feedback on it. So took a look at like a more production-oriented kind of approach. Like once I started riding the bike around, I machined all the lugs, which is a little bit unique. Like a lot of people with that construction methodology right now are 3D printing them. So I had a couple people who know a lot more about bikes than I do introduce me to some of those builders and kind of look at them and what they're charging for the bikes. And with a bit of background in material sciences and understanding some of the limitations of 3D printing, that's when I decided to really kind of lean into doing the machined lugs and then producing the carbon tubes here as well.
Yeah, the immediate feedback I've received about the bike is everyone's saying, okay, it's an Elan or a Vitas from years ago. And
Yeah.
obviously, that's not even near the truth. Can you just give us, I guess, a little bit of the background and what goes into the frame construction, what differentiates yours from those now very ancient bikes?
I don't have an intimate knowledge of how they were built at the time. The main thing there was it was in a transitional phase before monocoque carbon existed, and I believe they were still using cast lugs. The way that an old alloy bike would have been built back then was they'd have investment casting tooling to make the lugs for a braze frame out of steel. And so I think they transitioned over a lot of that technology and just basically replaced the alloy tubes with carbon tubes and hope that it was all going to work out well. So there's a couple things there that are problematic from a kind of longevity standpoint. One is that the sizing of the tube isn't quite right. To make a carbon tube as strong as an equivalent alloy tube, you actually have to make it quite a bit bigger diameter. The other thing there is that a lot of the metallurgy in the cast lugs is probably not as corrosion resistant as some of the others. So there was a lack of knowledge about some of the failure mechanisms from the bonding, galvanic corrosion being a big one of them, but also the adhesive technology just wasn't there back then. And they were combining it with sort of geometrically not appropriately sized profiles. And then oftentimes, like, not a lot of joint overlap. Like, you don't need a lot of joint overlap for a good brazed connection compared to like a bonded alloy to carbon.
So going back to the bike you sent to me, which, well, I have to say is a pretty amazing bit of kit. More about that later in this video. It was a custom bike. I provided geometry for you to build the bike from, but obviously alloy lugs that are machined and carbon tubes. I guess tell us about some of the carbon tubes and other tech you've got going inside the bike at the moment.
Yeah, so the main differentiator between us and most of the other current brands making lug frames is that they're all using 3D printed lugs, predominantly SLS, which is selective laser sintering. That's the acronym for it. So they have a really expensive machine that they put powder feedstock in, and a laser kind of melts it where you need it to stick together. And at the end of the process, you're like Indiana Jones, the archaeologist, digging the part out of the powder bed. And that has a lot of kind of problems metallurgically. You're dealing with something that's molten in one part of it and solid in the other. So you have a huge heat gradient. And you also have very rapid cooling. So your crystal structure is not ideal there. So what you end up with is a material that is much more prone to like brittle failure, but also fatigue failure. So in aerospace, like the background where we were introduced to that type of stuff, they have to take the printed part. They don't not only heat treat it. A lot of people still heat treat it to get you kind of remove some of the residual stresses, but it won't really improve the grain structure. So it has to go on to a further process called hipping, which is hot isostatic pressing, where they basically put it in the world's most intense pressure cooker and raise it up just below the melting point and put an ungodly amount of pressure on it to basically squeeze all the metal down. And that's prohibitively cost. Like you just can't do that on a bike. So what you'll end up with is just kind of like a really expensive, like a 3D printed part is quite expensive and not that great. So for me, we have a machine shop and that's what I do. I design and machine complicated components. So I thought I'd make it out of billet aluminum, which is not as sexy as titanium. You know, titanium definitely is the buzzword that needs to be matched in the bike world, but pound for pound, it's kind of like just as strong, right? There's no comparison of a carbon tube to a alloy tube. Like you need to make the carbon tube a lot bigger, but it will be lighter. But if you were given, like if you needed your through axle to be really strong, you want to make it out of steel. Making it out of carbon fiber, it's going to be way weaker than a steel axle because when you're constrained on size, you can't do anything. So aluminum is less dense than titanium. So you can make the parts a bit bigger. They'll be just as strong, but because they're less dense, it comes out to the same weight. So the machining also has an added benefit of like really high accuracy. So that's where some of the idiosyncratic design choices on our bikes, like putting the bearings right into the frame, we can do that really without any, it's the same way a hub is built. There's no reason a bottom bracket shouldn't be done the same way. It's just really challenging to do that on a production frame. Lugs all start from solid blocks of aluminum, and we're using subtractive manufacturing. So we're moving material away to arrive at the final shape. But all that is automated and it's driven by the 3D backend that designs the bike. So when you send me your geometry, we plug in your fit data, their handling characteristics, and all the things that kind of define the bike. And your set of lugs is unique to your frame. Like I don't make two of the same bikes. So all those components, they'll look visually the same. If I laid them out like two bikes of a similar size next to one another on the table, you wouldn't be able to pick out which one's which. But say like a really tall rider, you're going to be able to look at the head tube and say, okay, that's markedly different. I can visually see that. But so the beauty of 3D printing is that the machine is somewhat agnostic to the incoming geometry. It doesn't care, right? It removes a lot of barriers to entry in terms of having to know how to make something. It just it's not as simple as just hitting print, but it's a lot closer than what you have to do with CNC machining. So the way that our parts are milled, all the back end tool pathing is automated. So that was really the big design challenge for how we developed the production of the bikes. And then the question about the carbon tubes, again, we wanted to not just kind of do the same thing everyone else is doing. A lot of pre-preg gets used. So we built a filament winding machine, which means we start with a single strand of raw carbon. It's like there's no epoxy mixed into it yet. And the machine winds it back and forth on a mandrel. And we add a proprietary resin system to that. So it's sort of, again, an atypical product in the bike world, but it's used more extensively in aerospace. So it's a highly toughened resin system. The kind of gimmicky buzzword is that it's a nanoparticle. It's really fancy stuff, but what it means is that the tube's not going to break down over time. Like most carbon failure doesn't come from the fibers breaking apart. It's that the actual resin starts to fatigue over time. And then the fibers can start to get bent more than they should. And that's where it comes apart. So it's kind of like a two-stage thing. So the other thing we do with the tubes is there are other builders that use filament wound tubes, but a lot of times they wrap it on the mandrel and then they shrink tape it. So they cure it right on the rod that they've wound it on. But that you're basically trapping all the air bubbles and crap that you can't wind a tube without introducing a bunch of kind of micro air bubbles into it. So if you just shrink tape it, you're just kind of crushing what's already there. So you end up with like micro voids in it, which again, that's what composites start to fail from typically, is little voids. So we take a couple extra steps. We remove the mandrel out of it. We then put it into rigid tooling. So we cut all our own molds in-house. So we put the wet carbon fiber sleeve essentially in a mold, put a bladder into it, It then goes into a vacuum chamber for some amount of time to draw out all those tiny bubbles while the resin's still liquid. We then pressurize the bladders to 400 psi to really crush them against the mold. And that all takes like, if you were to put a normal composite layup at 400 psi bladder pressure, you're just going to squeeze all the resin out of it and you're going to end up with something that's really dry. So the accuracy of our molds, just having a background as a mold maker, that's a part of it, but then also the resin profiling all has like the viscosity, the point at which you in the temperature profile start to hit that pressure. It all kind of like plays a critical role in making a tube that is as strong as it can be, has a really good lifespan. And then for us, the accuracy on the tubes is also really important because we're gluing them into the lugs. And you need to really particularly control that dimension because too much glue or too little glue are both really problematic for the joints longevity. So it's about the thickness of a sheet of paper worth of glue around there. Any too much more than that, like when you go to 2 sheets of paper thick, you start to get the glue can act rubbery and peel away. So it's all like, some people will give me a hard time on social media, like, oh, the accuracy doesn't matter. And it's like, well, it doesn't, a bike doesn't need to be that accurate. But if I want to put out a product that like stands the test of time and is worthy of the price point, you kind of have to care about all those little things.
You've got a really active Instagram account. I know you show a lot of your build process, and people definitely should check that out. I'll have it linked in the description below and the little box on screen. What changes have you got going on since the bike you built for me? I did notice you've got anodizing available now as well on the lugs, which is pretty sharp.
Customer facing, the anodizing is probably one of the bigger things just because the bikes can now have a different kind of visual palette. The electroless nickel plating we're using before only comes in that kind of off gray silvery color that your frame is. We were originally using electroless nickel because anodizing vendors near us weren't able to maintain the thickness tolerance we needed. Again, because the bearings go in the frame, we actually need to hold a fairly tight tolerance. People who take bikes apart will kind of know that some like hub manufacturers would be a good example. They might anodize the entire hub, but then machine the bearing seats after. So you'll have your hub bodies all black, but when you take the bearing out, there's a silver bearing race there. And the reason they're doing that is because controlling anodizing thickness is relatively challenging to do at the tolerance you need for bearing fits. I originally wanted to use anodizing because it's really good for galvanic corrosion. It's essentially electrically inert. You're growing like glass or sand on top of your aluminum part is what anodizing is. It's aluminum oxide. So if you took a multimeter and touched the back of your MacBook Pro, for example, it's not going to conduct electricity because the anodized layer insulates it. So that's very, very good for galvanic corrosion. The vendors basically just laughed at us when we said, hey, can you hold these tolerances? Electroless nickel is very good in that it's quite hard. It's got some good corrosion resistance properties, and their tolerances were really quite tight enough for us for the bearings. They can hold 4/10, which is, I think, like 2 microns or something like that. So that's adequate for the bearing fits. But we were starting to run into some issues with the vendor where, we'd have a quality problem. We'd go back to them and they'd not really give you a very warm and fuzzy feeling in your stomach, a bit of that. And then also seeing some like failure mechanisms where like, say you got a really bad rock strike on your bottom bracket, the plating might start to flake off where it was impacted, where anodizing, you can still scratch through anodizing if you try hard enough, but it kind of deforms with the material a bit better. So that was the motivation that really pushed me to bring the anodizing in-house. So we now have an anodizing setup here where I can control no one cares about my parts as much as I do. So I can control the accuracy because I'm doing only my parts. Like I do a single bike at a time. Whereas if I was to send it out to a job shop, they're going to put it in with hundreds, if not thousands of other parts, and they just can't give you that dimensional tolerance. So the added bonus from the consumer's point of view there is that we can do colors now. So I think that's kind of fun to play with. All the bikes that I've sold up to this point that have the nickel plating, I'm replacing them all. Like I'm calling it under warranty. I'm not happy with what I'm seeing. They'll get like staining on them has been one thing I've seen on some bikes. And then these bikes are all over the world in different climates. Like I'd be curious what yours looks like in a few more months of being in a relatively humid and hot place. Like I ride mine all winter long in salty Southern Ontario. I've got people with them in the desert. And there's no rhyme or reason to some of the stuff we're seeing. So that really makes me think it's a QC issue with the vendor we were using. I don't have that many customers right now, and I certainly want them all to be extremely happy with the bike. So that's one reason for swapping them out. The other is to change the tube profiles, which I think you were alluding to earlier with your question. So your bike has all the tubes in the front triangle round, your seat stays are round, and then you've got the kind of rectangular chain stays. We still can offer those as an option if someone's very particular about wanting the aesthetic of like a round bike. But what we're starting to do now is play with way more shapes on the tubing. So again, that's all part of the 3D model where a bike can have different amounts of elliptical tubing if we've got the molds for it, the new down tube, right? And you can kind of see that it's quite a lot flatter. Another major change is the chain stays. So I've increased the height of them quite a lot near the bottom bracket. That's just to allow for more bottom bracket stiffness if the customer wants that. So this kind of tapered section where it drops away, I can actually play with how much of that gets used. So I could bring it like really close into the bottom bracket so that the chain stays more approximate what's on your bike, which is the smaller gauge all the way front to back. And then within here, we can play with different layouts on the winder. And then the more dramatic one is the top tube is quite elliptical now. So relatively fat. And that's to try to help get a bit more front end compliance without sacrificing, stiffness through the handlebars. Yeah, those are the main changes to the tube profiles. And again, we can still wind different patterns within each of those tubes for a given bike. So we've got a lot more. I think this isn't like the bikes before, I wouldn't say are bad. This just gives us more option in what we can do in terms of tuning differential stiffness, much sought after vertical compliance and stuff.
One of the most overused vernaculars in cycling journalism, vertical compliance and supple and all sort of stuff.
Yeah, but and in a way, especially the chain stays, a lot of those choices were basically just to mitigate preconceptions that people might have. I've had a lot of people say, come up to the bike, they've not seen one before, look at it, oh, those tubes are all way too skinny, it's going to be like a noodle. Like, well, okay, I can't change your mind about that. You're based that on your own history and knowledge of bikes you've ridden. That's totally having the stays that look a little bit more modern, if you will. I'm hoping just, they pass the visual gut check for some people more easily. So
I can attest that the bike, every time I've ridden this bike and every time I've spotted anywhere, it stands out and people always ask me about the bike. And this was the bike that featured with Shimano's press camp for the GRX Di212 speed group set. And I mean, I may be a little bit conceited here, but it was definitely the most interesting. I thought the best bike at the camp. It stood out from the sea of boring carbon bikes that were present. But
we were offering it at the time you got the bike, but you and I agreed that for a Shimano build party, it was maybe not the best move to put the UDH hanger on the back. So it's pretty much all shipped with that now, unless someone really specified otherwise. I know as an independent builder, I think it's, there are some things I don't like about the UDH from the constraints it puts on the frame design. But what I really like is just that a customer of mine isn't going to be left out. If something happens to me and they can't get a hanger replacement, this is any bike shop, you can pick them up. There's also, of course, now the added benefit of the SRAM direct mount.
Well, that's the thing I like about your company. You're basically a one-person operation, and you can get anything you want, a full bespoke bicycle. And, the price you charge, sure, it's not cheap on paper, but when you compare it to some of the big name, big brand offerings, it comes in way less. And it's like, I understand why people would buy this mainstream bike versus something that's really unique and bespoke for them.
I think if you talk to a non-cyclist or someone who's just peripherally a bike rider, they're going to say that's a crazy amount of money. But they don't know what like a Pinarello frame set from China costs, right? It's things that we're doing now. I think I was working on it when your bike went out, but the stems are now shipping with the bikes for people that want them. And then the seat post is pretty close to being completed. We don't have a setback option right now, but for a straight 27.2, it's kind of completing the frame unit, if you will. Our website definitely needs some work. It's pretty basic right now. That's kind of something that's happening in the background. But as you mentioned earlier, as a one-person shop, it's tough to prioritize that. It's frameworkbicycles.com. Our Instagram is definitely the best place to check us out if you're an Instagram user. Framework Bikes is the handle there. Like you mentioned, I try to post a lot of behind-the-scenes content, what's going on in the shop, how we make stuff. So yeah, those are the best two places to find out more.
Okay, trendsetters, that wraps up the interview with Jonathan of Framework Bicycles. Jonathan, thanks very much for your time. Folks, I hope you found this interview to be insightful. It's not every day you can name the builder and meet the builder of a bicycle you might be riding. And don't forget my review of the custom Framework Bicycles gravel bike. As always, thank you for watching. If you haven't already, please consider subscribing to the Gravel Cyclist YouTube channel for fascinating insight videos such as this one. No bull gravel bike reviews, other product reviews, ride experience videos, as all of it is released to the channel. We'll see you in the next video.